I created this short video to show you how to use the shape table in determining molecular shape of your covalent compounds. So get out your shape table. When looking at your shape table, we really only care about the last three columns. You're going to have to do the Lewis structure of your compound. And then once you've completed the Lewis structure, our focus is on the central atom. So here is an example of a Lewis structure, nitrogen trihydride, and our central atom is this guy, the nitrogen. So when we look at nitrogen, according to this first column, what we're interested in is the number of atoms that are bonded to that center. So we have 1, 2, and 3 atoms that are bonded. I'm not looking for the number of bonds, I just want to know how many atoms are bonded to it. So in my first column, I'm looking at the 3, so I'm interested in that one and this one. Then I go to the next column. I want to know how many lone pairs are on the central atom. So again, I'm looking at center, and I see that there is 1 lone pair. So it's not going to be that one, because that says there's no lone pairs. I'm looking at this. So my answer is trigonal pyramidal. That's what I would write down on my paper. Here's another example. Again, you're going to draw your Lewis structure using the enable method. Once you have your Lewis structure, we're going to focus on center. Our center is carbon. What I want to know is how many atoms are bonded to carbon. I've got 1, 2, 3, and 4. So I'm looking at this one right here, and that is the only option I have. But just to verify, the second column says how many lone pairs. When I look at carbon, I see there are no lone pairs. So my answer would be tetrahedral, and that's what I would write down. Alright, in this example we've got H and F, hydrogen and a halogen, and we know typically they're not going to be center, either one of them. But we know without a doubt hydrogen will never be center because it doesn't even like lone pairs. So in this case we're going to pick fluorine as our center. And remember, typically what you're going to do is you're going to look at your electronegative. It's the least electronegative element that is your center, except for hydrogen. Alright, so when we look at fluorine, we see that fluorine has, okay, so fluorine is our center. We see that fluorine has 1 atom bonded to it. So I'm looking at either linear or linear. And then we can just double check. It has 1, 2 lone pairs. So it is linear. Alright, thank you for sticking with me, and that is how to use your molecular shape table in order to determine the molecular geometry of your atoms, of your compounds. Thanks.